Welcome back, math fans. We are looking at simplifying radicals today. So we are going to do that for lesson 4. This is simplifying radicals, right? So one of the big things that we want to be clear on is radicals can be written as fractional exponents. So some examples of that is we just know that like root 2 is the same as 2 to the 1/2 as an exponent. Good. So that's 2 to the 1/2 as an exponent. So if I have x to the 4th root, right, and we're always looking in that index, right, that root there, that's just going to be x to the 1/4, right? That was one of the exponent laws we looked at previously. And so as a generalization, we're just going to say if I have n, a, right, with base a and an index of n, that's just going to be a to the 1/n. Good. So 3 important rules of radicals. Anytime that I have n to a over n, that's just equal to a, since this will become a to the n over n, and anything divided by itself is itself. So that's just 1. Okay. Another important rule is that we can take n to the ab, and what's going to happen is I can break apart a radical into 2 separate radicals, a and b, like this, as long as they have the same index and root, right? And all of these are for a and b greater than or equal to 0, right? So I can do that if they all have the same root there like that. And then finally, for fractions, I'm allowed to break it apart from one fraction into 2 pieces. So if I have a over b, I'm allowed to break it into a radical on the numerator and a radical on the denominator, just like that. Totally okay as long as the index stays the same. Okay, that's good. So we're totally okay with that. I could show you the reasonings, but these are the properties, and the book kind of does the same thing there. So let's use these properties in a nice, clean way. So let's do number 1 here. So for 1, we just want to simplify root 20. So that means make it a mixed radical. So what that tells me is that I want to find the pieces that are square in here, right? So I can do that by making a factor tree, or if I know what is square for factors already. Well, I know that 20 is 4 times 5. I'm just going to break it apart. Well, this piece here gets to go down to 2. So I'm going to take the 4 out, and then I'm actually going to get 2 root 5. And we're not going to actually get to like why it's useful to do this right now, but we want to practice this skill because it's going to be useful to us in a couple lessons. So it's just breaking it down, right? We want to find the perfect square factors that are inside these radicals. And so sometimes we might be, like if we have this example here, we might be looking for perfect cubes, right, in 24. Well, if I look at 24 on a factor tree, 24 is 8 and 3. If I look at my list of perfect cubes, I'll have 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed. Well, that's just like 1, 8, 27, 64, 125, 216. Ooh, let's see. 7 times 7 is 49. 50 times 7 is 50 times 7 is 350. 350 minus 7 is 343. This is 343. If you're like, how did Mr. Van Dyke do that? Just go back to the playback, listen to the tape, right? So check the tape. So this is perfect square factor over here. So I know this is going to be cube root 8 times cube root 3. And this cube root 8 simplifies down, and it's going to become 2. So I'll get 2 times cube root 3. Because this multiplication operation that was happening there between the two radicals is still going to be a multiplication still going to be a multiplication operation when that comes out of the radical, right? It's still multiplication inside or outside the radical. All right, let's look at another one, but let's introduce some variables to the mix. So I'm going to get 180, x to the 6, y to the 3rd, but I'm just going to make a note here that x and y are both positive because I don't want to have to deal with absolute values if anything falls out. What I'm going to do, and this is a square root, is I'm just going to actually just keep different, like I'm going to put different things with different things. So I'm going to put 180 by itself. I'm going to put x to the 6 by itself. I'm going to put y cubed by itself. And so 180, I can see that this is, well, it looks like 18 and 10. So if I do that, well, I know that 180, that's going to be 9 times 20, right? Okay, 18, 10. I just want to find perfect squares. That's 4 and 5. So I have a perfect square in the 9 and a perfect square in the 4. So that's going to come out as 3 and 2. That'll come out as 6, but I'll have a 5 left over. So this will be 6 root 5 because the 6 is coming from, this will jailbreak as a 3. Well, let's actually just write the step here. This will be root 9 or root 4 or root 5. I'll worry about the x's in a moment. But now that root 9 becomes a 3, that root 4 becomes a 2, and that root 5 has nobody to break out with. Okay, what I do know about that root 6 is it actually becomes 6 over 2 because it's a square root in here, right? If I have nothing in the hook, it's actually a square. And that simplifies down to 3 like that. One thing for this y here, you can take this and it's 3 over 2, but it's not clear what to do there yet. But I'm going to do this. If I had 2 over 2 and 1 over 2, it follows our exponent law of 2 over 2 plus 1 over 2 is the original, and that would get me 3 over 2, right? I'm just going to break down the whole number pieces. I'm looking for how many factors of y there are, and that just makes 1. So let's put everything together now. And this is going to be 6 root 5 x cubed, and this is going to be y, and this is going to be y there. Okay, here's what we're going to do. So now I'm going to have 6x cubed y, and I have 5 and root y. Oh, man. Let's put this together. 6x cubed y, 5y here. There we go. That's it. That's what we're looking at. So we're just going ahead and we're saying, okay, this is just going to be, we're going to combine the things under the radical that should be with the radical. Everything outside of the radical lives with the radical. Okay. The next examples will go a little bit more quickly since we got that a little bit more taken care of. Look at something with a fraction. So I'm going to have the cube root of x to the 12 over 64. And I know that this is going to be x to the 12 over 3. And this will be 64 to the 1 over 3. I know that 12 divided by 3 is x to the 4. And 64 to the 1/3 is going to be 4, right? That the cube root of 64 is 4. And that's it. That's the answer, right? So I can just find those groups, make it happen. I'm just applying that root separately to the numerator and separately to the denominator. All right, good. So that's that simplifying radical portion there. Let's look at mixed radicals. So now all we're doing is we're undoing this operation now. So we're going to undo the operation and put everything together now. So we're going to, let's just make this clear. So we're going to undo the operation. And now I want to write 3 root 5 as a whole radical. Well, what's the part that's not in the radical right now? The 3. And it's a square root, so I need to square the 3 to get it under the radical, right? Root 9 and 3 are the exact same number, but root 9 is living on, like the 9 here is living under a radical sign. And I want to be under the radical, and this is going to be root 45. Amazing. There we go. That's root 45. So it's back there. Let's try it with some variables and a little wrinkle with a negative here. Trying it with a variable, we're going to have minus 4x squared. And we have a root of 5x cubed. And again, for these, all of these, we're just going to take x to be greater than 0. And we're going to just take, for all our mixed radical, x, y are going to be greater than or equal to 0. Let's do what we know and just make it work for us. I'm going to Actually, no, we got to contend with this negative first. We're not going to just do what we know. This negative is not going to go under the radical sign because if I square the negative, 1 squared, if I make it, write it on the side, 1 squared is equal to 1. That, if I put this in the radical sign, I'm losing information. And I can't take anything into the radical sign that's not squared first. I have to square it to put it under the radical sign. But I change what the number is if it goes under the radical sign. Here, when I put 3 in the radical as root 9, the number is still the same. But here, negative 1 and 1 are way different numbers. So this negative still has to live outside the radical. But I'm just now going to get 16x to the 4th because x squared is going to be 2 times 2. So that's x to the 4th. This is, let's just be clear, that's 2 times 2, not 2 plus 2, 2 times 2. That's how the law works. That'd be x to the 4th. And this will be 5x cubed. As I'm doing this, this will now be put together. I can put them together. 16 times 5 is 80. So I'm going to put the whole radical together. So this is 80. And then x to the 4, x to the 3, that's x to the 7. And I just like to end my radical with this little hook so you can see where it finishes. All right, 2 more, and then we're on our way, okay? And let's pay special attention to that last one. So here, I'm going to have 2xy cube root 4x squared y cubed. And let's make some adjustments here, just like that. Perfect. Okay, and what I'm going to do there is I am going to have put this together, 4x squared y cubed, and I want to get everything cubed now. So 2 cubed is 8, x cubed is x cubed, and y cubed is y cubed. So, and this is all going to live together under a new cubic radical, like a new cube root. This will be 8x cubed, y cubed, and this will be cube 4x squared, y cubed. So what's going to happen, I have everything under a cube root. It's like and like, right? So whenever I combine it, I'm going to check the hooks to make sure I can combine it. I can only combine it if the hooks are the same, and now they are. So 8 and 4 is 32, 3 and 2 is 5, and 3 and 3 is 6. So I'm going to get the cube root of 32, x to the 5th, y to the 6th, just like that. Hook it closed, and we got it. Math fans, we are blazing. All right, last one. This is my favorite example, and I'm going to use this again and again because I just love it so much. Fractions are like, for people, I find it's like very, very cut and dry. It's like, for some people, seeing a fraction is like seeing a spider in the shower, and it's like, oh man, I am not dealing with this. I am not paid to deal with spiders in the shower. And some people are like, yeah, that's what it is. I'm gonna keep going. Love a challenge, right? And I don't think like there's a strong reaction one way or the other. All right, so as we're doing this over here, let's just remember that this whole denominator with the radical has a denominator of 1. So I'm going to rewrite it quickly, a little bit faster than I was writing my saying my spider story. I'm going to write it like this, and I get 2xy squared over 1. And what's going on here is that I can see that this denominator is going to go here, like with the cube root, and that'll go there. So just checking cube root things, 3 cubed is 27. X squared cubed is x to the 6th. Y cubed is y cubed. And 5 cubed is 125. So let's put all those pieces together. So this will be 27 x to the 6th y cubed over 125. And this is all under a cube root. And this is all under a cube root of 2x y squared over 1. And now we just combine numerator and denominator. 27 times 2 is 54. So I'm going to get 54. X to the 6, x to the 1, x to the 7, y cubed, y to the y squared, y to the 5th. The only thing on the bottom is 125. And I'm going to take a gigantic cube root right here that goes around the entire fraction. And that, math fans, is the whole math story. All right, thanks for sticking with it through the entire video. I love to talk about math. Like, I probably could have spoken about each problem in so much more detail. Sometimes it's painful that, we're on a time limit and we can only talk so much about it. But for me, if you really, really, really want to get there, what to do is to just go ahead and just get your practice, because you're going to build that intuitive understanding that words just can't reach. All right. I believe in you. I have faith in you. Your math teacher thinks you're amazing, and I want you to do the best you can do. All right. Mr. Van Dyke, out.